Hello and welcome to today's webinar presented by Machine Design, New Equipment Digest, and EHS Today. Our topic today is building a machine safety mindset, sponsored by Schmersal. I'm Bob Vavra with Endeavor's Design and Engineering Group. Let's talk about how you can participate in today's presentation. If you have any technical difficulties during our session, simply hit F5 to refresh your webcast console. If you need additional assistance solving common issues, please click on the yellow help icon below the slides. This webinar technology also allows you to resize the presentation by clicking on the maximize icon or by dragging the lower right corner to enlarge the window. We also welcome your questions during our event today, and we'll get to as many of those as we can during the Q&A session that'll follow the main presentation, so feel free to send in your questions at any time. To do so, simply type your questions into the question window on the side of your screen and hit the submit button. Also be aware that today's session is being recorded and will be available on the Machine Design website as well as on the websites for New Equipment Digest and EHS Today following this presentation. You'll be notified by email when the archive is available. Our speaker for today is Peter Rogakos. Peter's a licensed professional engineer who started his career in electrical engineering, designing and reviewing automated safety systems, primarily from automotive manufacturing facilities. Since then, Peter's gained extensive knowledge in machine safety for various industries, allowing him to obtain his TUV Functional Engineering certification. You can learn more about Peter by clicking on the blue speaker bio widget on your console toolbar. Peter's safety is a huge concern and a huge interest for our audience across all of these titles, and we're really looking forward to your insights today.
Thank you, Bob, and thank you for the kind introduction. And hello, everybody. Thanks for joining today. Before we get into the webinar, I wanted to share some background as to where this topic came from. So as many here today probably felt when you entered your chosen career, personally I was excited to make things work as a young electrical engineer. The program I was involved with taught me a lot of interesting topics, but none of it discussed design of safe machines, so which I still think is the case today in many engineering programs. Out of college, one of my first projects was working in a foundry, upgrading the safety controls on a machine that had recently poured molten metal over an operator. Fortunately, the operator lived, but as you can imagine, with serious, non-reversible injuries. After seeing what harm machines could offer, I quickly gained a respect for machine safety design. I also saw the stress plant managers face with not only the guilt of someone getting injured, but also dealing with the fines and stoppage in production. That accident was more than 15 years ago. And since then, personally, I've gained a lot more knowledge and experience in machine safety. I've learned that designing a safe machine and following safety standards is great. But the companies or individuals designing equipment that do it the best always have a machine safety mindset. So today's discussion is sharing these experiences over our time and what separates building a safety machine over having a machine safety mindset. I want to start off with showing a document published by OSHA, which shows the most frequently cited serious violations in general industry for 2019. Here you can see machine guarding is in second place with 1,280 violations. Typically, when this report is issued, typically in most cases, machine safety is always in the top 10, and it changes. Now, if we dig deeper into the same document, we can see which types of machine guarding hazards were violated. And as most of us here will agree, I'm sure that the violations were not deliberate, and I'm hoping that none of them were negligent. But during my time helping customers work with OSHA to discuss violations and assisting in providing solutions to better safeguard, I've noticed one common thing. The knowledge of how to protect such hazards is not common. So for example, if I take 10 people from this webinar who are not machine safety experts, and I put each of you in a separate room with the same machine to guard, I believe each of you would come up with 10 different solutions. So some may make it bulletproof, and I'm sure we know those people that make things bulletproof and safety, and others may say, hey, we don't need a lot of this. We'll put a yellow line on the floor with a sign that says, do not cross when the machine is operating. And I'm sure you've met those kind of people too that believe in that, right? However, my point is, I believe each of the 10 people would make 10 different safety designs. So now imagine if you take those 10 people from the same company And if you take those people from the same company and they're making 10 different safety designs, this could be really bad for safeguarding design over a period. So over my time working in safety, I've noticed that each person has their own idea to what is safe. So if we look at people designing the equipment or maintaining the equipment, how could we not expect them to apply what they think is safe? So a common example is when we get a call for someone and they're looking for an emergency pull cord. And for the people here that don't know what emergency pull cord is, it's basically an emergency stop button, but it has a cord. And usually it's along a long conveyor where someone can pull on this cord anywhere and it'll stop the conveyor or any apparatus. A lot of times when we get called, many times I'll dig deeper into the application and say, well, why do you want to use a pull cord? And a lot of times you'll hear people say, well, if someone's getting pulled into the machine, if they're injured, they can reach over and pull this cord and stop themselves, right? And that's true. Maybe they will. But are we defeating the purpose? Are we using the wrong device for the application? Right? And honestly, in their defense, they don't know other technologies. They saw a pull cord somewhere. They said, hey, I can use this for this application. Maybe they don't know what technologies are out there. However, are we using the technologies correctly? And in this case, it's not correct because we want to prevent people from being hurt. In that instance, you've been hurt. So this is one of my favorite studies in safety. It was done in the UK over a sample size of 34 machines. So it's a low sample, but the results are pretty incredible to me. You can see that safety requirements specification part of each project resulted in 44% of system failures in the study. So basically, these 34 machines failed at some point within safety, and they analyzed what happened. And you'll see a big portion of those specifications. So if we compare the slide before about the pull cord example, are we using the right devices? Are we specifying the right ones? Right? So basically an incorrect design basis. Now, if we're designing an implementation, that's 15%, although is really high as well. And where are we designing the equipment? So maybe we do pick the right device, but are we implementing it correctly? So this always sits with me to understand where the issues come from when we're designing equipment. So now that so far in this presentation, we've established that machine guarding is one of the most cited violations in OSHA, and that it could possibly be because of many factors. But that study points out to specifications and other issues that could happen. So where do we go from here, right? And these are the building blocks that we want to create that build our foundation and our mindset. So we have some statistics, we have some facts. So how do we go about building this and preventing and making ourselves better? So in the next 5 slides, I'm going to ask some questions. And I would like each of you to think about each question and ask yourself if your company can accomplish this or your establishment. Can we accomplish this? So the first, which consensus standard applies to your company, right? And again, this is something, standards can get intimidating in the sense that there's so many. There's so many ISO standards. There's so many ANSI standards. But which ones we can find that apply? And there could be over 1,000. I don't know how many there are, but there are many. But I think you'll be surprised to find that maybe 2, 3, 5 apply to your facility in your industry. So there's many out there, but which apply to you? And I don't think that there will be many. There may be 3 to 5, for example. So, and now these do get intimidating because there are so many, but can we narrow it down to the ones that apply to us? And which ones? Now, these are, on the screen here, you see many different standards, but we want to choose which ones apply. Can we simplify these consensus standards or customize these standards to our use? So we want to take these standards that we've chosen, the 3 to 5, for example, that apply to your industry, and can we simplify them? And when I say simplify them, I don't want to make them more unsafe. I don't want to pick and choose what we think we like and what we don't. We have to choose things that actually matter and what mean to the safety standards. However, we want to be sure that we're simplifying it and making it easy for our people. So if we look to the right of the screen, you see a locking door interlock. There's a silver handle and a red handle. And this applies to the robotic standard. And the robotic standard is a Type C standard very specific to robots. And in that standard, the robot standard, it says that if you have a person entering door, if you can walk through a door, a machine-guarded door into a robot cell, you must or you shall have emergency release from inside the cell. And that's what the red handle is. So you should be able to get out of that cell at any point in time when the robot's functioning or not. Now, this is only applied to robot standards, but is this an example where we can simplify and say, you know what, not only do it for robot standards, I want to do it for my whole facility. All the doors I use, any kind of person entering door, I want to use this. Now, you may argue it's a bit expensive or, that's too much to do. But however, it is a possibility to make it easy for everyone. It just has it across the board. It's not only on robot cells. Another example we see quite a bit is on the left, and not to get too technical, these are performance levels. And what they have to do with is they have to do with circuit design. And if you're designing a circuit, like the door interlock on the right, we have to design it to a certain level according to our risk assessment. And we'll get into that. But you can have a low risk of A or a high risk of E. So A, B, C, D, or E. And a lot of companies have chosen to say, you know what, our minimum design is D. We don't, if your risk assessment comes with a C or B, just make your minimum design a D, right? So again, you're simplifying it. You're making it easier. So now your designers know that, you know what, our minimum's a D. Although we have to do a risk assessment, we know that we have to design to a minimum of a D. Now, we've taken these standards, we've figured out which consensus standard there are. And again, I wanted to talk about standards where these standards are referred to by OSHA. OSHA likes, if you need more information in regards to OSHA rules, you use a standard. And now these standards, once we've chosen and simplified, we've chosen which ones apply to us, we've simplified these standards and the examples we've used. Now we want to put them into our company standard. Now, some may think, I've seen some where, you're copying and pasting stuff. And what I want to get away from is I don't want people to think here that we're just going to copy and paste the things we like into one standard. It's going to be a bunch of verbiage, right? We want to take this standard. We want to take what we like, put it into a company standard, but we want to elaborate. Because standards sometimes are vague. If you're reading them for the first time, they're very vague. We don't know exactly what they mean or what they're saying. So we want to take what's in the standard, but we want to elaborate. We want to add things. We want to maybe even add pictures and images and explain that. We'll get into that further. So can specific machines have their own company document as a safety guideline, standard, or training? So some facilities have very unique equipment, very unique cells that they're using. And some may say, well, we can't find even an OEM machine builder to build these. We build them ourselves. But they may be unique. However, what happens is we find that a lot of these unique cells are used in different facilities, and they're all safeguarded very differently. Now, do we take this unique machine and create its own document and say, this is how it's safeguarded, and this is how we do that and share it along the companies? It could be, you could even do it for robot cells. This is how we want our robot cells safeguarded, and this is how we want our injection molding cells safeguarded, for example. We can also standardize on some training. You may want your safety PLCs programmed a certain way. You may, going back to the performance level D for wiring for safety devices, you may have wiring labs that are specific to that performance level D and E, and so on and so forth. So we may have those standards within our company standard. Can we add actual wiring diagrams showing how safety devices are wired to the safety controller? So this is important. This goes back to, we don't want to copy and paste and leave it vague. We want to explain. We want to take things from the standard, and we want to help. So these drawings, circuit drawings, are really important, for example, as a visual for the engineer or maintenance to see how are these things wired. As a young, new grad out of school, I never knew what redundancy was, and that's a common thing in circuits. And if I looked at this, I would say, well, why do you have two relays coming out of there? I would ask all these questions, but it would help me. And then I would have an example document. This shows a two-hand controlled wired to a safety relay. Sometimes we find that cells don't even have safety relays, which they are required. So again, the point here is that can you make it more visual and more in-depth? To take a standard, simplify it, and then explain it in depth for your engineers, your maintenance, and the people in your facility. Can we have images, drawings, or videos showing an installation should look like? And again, I know you can't add a video to a book, which would be great, but we can't do that yet. However, you may have a company website with videos showing cells. These images show the finished product of a cell with guarding. You may want to zoom in on devices. You may want to have an AutoCAD drawing showing the parts and pieces of what's used. But showing how devices are mounted and how they're used or a finished product, again, may help with your company standard to show your engineers, to show your customers how you're working with things. When I say customers, there are machine builders here that you may want to show when you're showing and building a machine. This is the company standard we follow. This is our safety. So if we can accomplish each of the questions we answered in the last few slides and put them into a company standard for everyone, there's no deny that it's helpful, but it's not the complete solution, right? So personally, in my past, when someone gave me a book like this of some sort, it did help and it put me on the right line, and some were better than others, right? I personally love to know where a company wanted their design to be and what levels and what depth. And other times we had to go run and look for it and determine it, right? But in honesty, the company standard was very helpful as a young engineer designing. So, but however, in some ways, it's perfect world thinking if it's not introduced correctly. So creating this standard is great, but simply sending it to someone and expecting them to use it correctly for the first time is not the best idea. The example would be like giving your 16-year-old kid, if you have, or a 16-year-old kid, an awesome book about driving, but then expecting them to drive to school the next day, right? Like I have 3 kids. I'm sure the one would get a speeding ticket, the other would drive on the grass halfway there, and I'm sure the third would trade my car in for a Corvette somehow. But my point is that all 3 kids would do something different, and we need to train that. So the basis is, this is the basis of our foundation, of our building blocks. We need this, we need to pick the standards, we need to guide people, but it's the basis of the next part being our mindset. What other systems and what other things do we have to do to create this mindset, but using our company standard as our foundation? So in parallel to creating that company standard, we have to have a training to teach fundamentals. And again, many here may think, well, we already do a lot of safety training. This is nothing new, right? And I guarantee a lot of it's great training, but what kind of training are we doing? What safeguarding training, right? This training should be like our mission, but with details and simplicity. But we need to teach it. And so it's got to be, the trainings I see that work are very impactful. And impactful in the sense is, we understand our why. Why are we doing machine guarding? And people that I've worked with, it's important for them to understand that they don't know why they do safety. Well, who would put their arm there? Who would climb over this barrier? Who would go under it? The goal is, I think, when you're transparent, you show past accidents. If you say, hey, 2 years ago we had this accident and this is what happened, I think people start to take it seriously. So transparency on accidents. You can use accidents from other companies as examples if you find them. What are the government rules and regulations, right? What is OSHA and what is a consensus standard? Why do we have to use both? One, there's a lot of misconception. One's not law, we don't have to use it, but the law says we have to use it. Just explain these things, right? Statistics help, to see a standard in place and to show people that we've implemented this guard or this design tactic and we went from 15 injuries to 3. Again, 3 is still too many. However, it's a lot better than 15. Do we have levels of training? Do we train our operators on how to use things and understand our why we have safety, why not to bypass things and what accidents have happened? But do we also do training for maintenance where we say, hey, a system might fail, your safety relay might go down. This is how you rewire a new safety relay. Maybe that safety relay is obsolete and you have to get a new one from a new supplier. Are we wiring it to the category and performance level that's required? Are we just plugging it in and getting power into it and just making it work? What is this safety relay doing? Do we have wiring, like back to those wiring labs? Do we do that? These are things we should ask, but again, an impactful training to show, be transparent, and determine our why. Why do we have it? Why do we have machine safeguarding? Our second mindset is risk assessment. And again, many here may be doing risk assessments. And for those of you that here that aren't aware of risk assessment, we're basically determining the risk on the machine and how severe it is. The higher the risk, the more the difference in performance levels and guarding that's required, right? And we look at severity, we look at the frequency of operation, how often are we using the machine, and the possibility of it happening, right, in a nutshell. But in my opinion, risk assessment is the best way to start off any safety project, to understand the hazards associated with the equipment. Now, it's nice to think you can take someone from your staff who has no idea and send them to a risk assessment training. And after a day or two of the training, they're ready to start completing risk assessments on various existing machines, not to mention any new machines being built. So from my experience, people new to machine safety are not comfortable completing a risk assessment, which will determine the safety requirements for the machine. Now, if we ask a new grad to complete such a task who is still learning about even industrial equipment, just been in a factory for a week, I'm not sure they'll know the ins and outs of what questions to ask, and we may get into problems down the road. So what I do is I like to call it a risk assessment apprenticeship-like program, where each risk assessment is done with a safety professional from within your company or a third-party company to train the apprentice on the risk assessment. So basically taking these, in my past, when a new grad came, first thing I did was pull them onto a risk assessment. And the reason why, it's not only to teach them what a risk assessment is, but what I call it, and for lack of a better term, I call it the safety eye, having that eye of determining safety. When you look at a piece of equipment, you see it function, you see how it produces, but are we looking at the safety hazards? And then do we result back to what we think is safe? A simple rule I used, and I still use today, is over, under, around, and through. You know, can I get over the guard? Can I get under the guard? Can I get around the guard? Or can I get through the guard? Is the guard fixed properly? I can't tell you how many times I've gone around the guard. And today, many people just, their idea of safety, they put a guard there, but I can walk right around it and get into the cell. Again, who would do that? But that's not the point. We have to understand that it should be guarded to protect some people. So when you work with that person on this apprenticeship-like program, and you do a few risk assessments with them, you teach them that safety eye. You teach them what to look for. Do we look under conveyors? And so on and so forth. So I think that's a fantastic way. And so, again, it takes time. You can't send them to a training. It takes time to teach them. The training does help, but we also have to have some hours behind it. Risk assessment is obviously done the best in the conceptual phase. If you're building a new machine, it's done when the machine's not even built, so you can engineer out any hazards. But now, I mean, the reality is there's a lot of people here, I'm sure, with equipment on that's been working for 10, 30 years, and they want to do a risk assessment. But it can be done that as well. We get the question all the time, you know, what template do I use? What standard do I use? And basically, there are standards for it. There is help, but the only thing we suggest is always using a standard document for everywhere in your facility. So if you're a multi-company and you have many facilities, use the same document, use the same risk assessment template. If facility A and B are using two different methods, then you're not consistent in your guarding. But again, it's the best way to teach people that safety eye, as I call it. So schematic review, the next building block. All right, and this is a part, and from what I've noticed, not many offer this or complete this, but it's an important part of reviewing equipment and is always part of a risk assessment, right? The controls, hydraulics, and pneumatics. There are three components. They're isolated energy we have to review. So now, depending on who's doing the risk assessment, we'll need that person to be versed in controls, hydraulics, and pneumatics to determine the level of safety. But from my experience, not everyone can read all of those, right? So personally, for me, when I do a risk assessment, I'm good at, I can do mechanical and I can do the control systems, but I don't do hydraulics and pneumatics. We have other people for that. So there are multiple people doing the risk assessment, and that's okay, right? So where does your facility or your company fit? Are you able to determine the mechanical? Great. But there are other parts of it. Do we hire that out? Do we train somebody? Do we have multiple people doing that? And it's fine. I feel that multiple people should be doing it because you have extra sets of eyes. But if anyone here today is having risk assessments done by yourself, by your people, or by a third party, I urge you to ask if the controls, hydraulics, and pneumatics are being reviewed. And if not, it's something to look into because it is part of a risk assessment and an important part to determine the levels of safety. Within schematic review, it's important to have documentation. Do we have the documentation? For example, this is Sistema. You can see an image of it. And Sistema, for the people that don't know, is a free software. And basically, you can drag and drop your safety devices in a system, and it spits out a performance level in a category, and it tells you where your category is at. And again, use it with caution because if you put the wrong information in, you'll get the wrong information out. But it's a good idea to have it done by a second set of eyes or a third party. So if someone does it, then you can have a second set of eyes review it. My point here, though, is that we need the documentation. We need to save this documentation and to get in the habit of saying, okay, sure, this system you're telling me is category 3 performance level D. You're telling me that it meets this requirement of our risk assessment, but I want documentation to show that. And so for my time now working, I mean, for most of you, I'm not sure how many know, but the EU requires these documentations. The EU requires that a system be reviewed according to certain standards and documentation provided. And so when I work with a customer that's getting a piece of equipment built in Europe, shipped here to the United States, right away I usually think, okay, they have the documentation, it's all good, it's ready to go, we don't have to ask for this. But in some cases, the companies will not share it, or in some cases it comes and it doesn't come complete, doesn't come right. So I don't know what the case, I'm not sure that's all the time. However, my point is that have a review, ask for the documentation and review it to see if it was done correctly. So similar to what we discussed in the last slide, many feel that if you're buying a cell or you're implementing a safety PLC, you're instantly safe. So that you instantly have safety, that's no problem. But although safety PLCs have many safety features to prevent unsafe programming, there's still a chance it can be programmed unsafely. So a review of a safety PLC program should be completed. So for example, sometimes if I see one, I'll open up a machine program, a safety program, and I'll look right at an electromechanical device like an e-stop. And an e-stop should have what's called test pulsing. It pulses the tests, and not to get too technical, but it should have test pulsing activated. And many times I'll find that it's not activated, right? And right away when you do that, you degrade your level of safety. You're degrading it. And a simple safety PLC review would determine that. On the slide, I have input side 1 and input side 2. And this is a story from my past, being a young engineer working on design. And I'll explain it. It was a robot cell, and on input, when it was on side 1, the robot would weld something, and when it was completed, it would swing over to side 2, and it would start another weld. But while it was welding on side 2, there was an operator that would take a part, remove it, and put a new part in side 1, hit a reset, and then the robot knew that it was clear to swing back to side 1. So it was working at the same time for more demand. Now, when production was low, and they didn't need side 1 and side 2, they had a switch there that would only allow the robot to work on side 1. So an operator would put a part in, come out, hit a reset button, the robot would weld, it would finish, go to home, and then the operator would go in and pull the part out. But what had happened was the inputs were wired alternatively, where side 2 went to side 1 and side 1 went to side 2. What had happened was when that key switch was turned, the side 1 where the welding was happening was bypassed. The light currents were bypassed. We did catch this before it went in. I mean, unfortunately, I didn't catch it. I was supposed to. My boss at the time caught it, which is unfortunate. It was a great learning lesson for me. But they caught that side 1 was bypassed. And so it was great. We found it before it went into production. But a simple safety PLC review determined that, and it caught that. And if an operator at some point wasn't thinking and walked in, they could have been hurt. Another issue, safety PLCs have function blocks in them. And these function blocks come from the manufacturer, and they're TUV certified to use in most cases. But they're also the ability in safety PLCs to create your own function block. And what happens is it's like a copy and paste. You reuse it to keep continuing to do programming. It makes programming faster. They're great. A colleague of mine we were working with in a facility that had implemented over 200 safety PLCs. We found one of the function blocks used was incorrectly programmed unsafely. So again, no one was hurt, it was caught, but it costed a lot of weekend work to go and upload over 200 safety and PLCs with this new function block. So those are some things we caught. No one got hurt, but again, it was a safety PLC. So you're not instantly safe. It needs review. Validation. So something that is not so common, but we've started to see more validation. So validation, it comes at the end of the project, but it's important to complete. Now the term validation is loosely used, for example. People ask, they'll call in and they'll say, hey, do you validate safety designs on machines? And 9 times out of 10, what they're asking for is if we can validate, we can do an assessment according to a particular safety standard. But the term validation in the world of safety is basically a process to test and confirm the safety circuits. So all the items we've spoken about up until this point, the review of the safety PLC, the standards, and so on and so forth, that's during the design phase and being sure you've chosen the correct methodologies, the technologies, and reviewed all the documentation to be sure we meet our safety requirements. However, when the system is built and we are certain there's no mistakes, are we certain there's no mistakes? There's no physical wiring. So a way to determine that is to validate the design after it's been installed and right before it enters production. So we want to do this at the facility and it's ready to go into production. We want to validate it. So if you see on the screen here, there's a circuit. I don't expect anybody here to be able to read that circuit, but the only thing I want to point out is that blue line that's on an arc. And what that is basically, it's a jumper, it's a bypass, if we want to call it that. And it's bypassing what's called the monitoring circuit. What monitoring does is if there's an issue with the safety circuit, when you shut your system off and your system's safe and you go to restart, it won't allow it to restart. The monitoring will not allow it to restart. And that's how we want it to function, right? What had happened was I was showing a customer what monitoring was. And I said, let's pick a machine, this new machine you have on yourself. We'll show you how monitoring works and why your system won't restart. Well, when I did what I was doing with the outputs, the system started. And I said, wow, that shouldn't happen. This is really weird. It's kind of scary, actually. After we reviewed and looked at it, someone, when they purchased a cell and they rewired it at their facility, I guess it was working fine at the site acceptance test, but not the factory, and it worked fine. I'm not sure if they even checked it. Someone had accidentally wired that bypass. It was at 24 volts that went right into that X7 input, right? That's essentially the same thing. It's a bypass. So a validation would have caught that. That is a very common thing to check during a validation. So the story it was crazy how we stumbled across it and we found it. But my point here is that if they did a validation on the cell, you would have caught that. Now, validation, there's no specific form or there's no specific, rules to follow. Basically, how you do it is each design, each machine you're doing, you basically choose your safety devices and you create a checklist. And I'll read out the first one here. This one here, channel 1, short circuit. Install a jumper wire between wire 101 and wire 102. And how the result, the machine dumps air, shuts down the motor. The machine will not reset until the fault is corrected. And so you issue a pass or a fail. And so basically you go through each of these safety devices and you check to see. Now, if you're thinking you're putting jumpers in, you're going to blow up a system, you won't do that, right? You set the plan up correctly and you do that. But it's important to do this where the machine is going to be in production, where it's going to happen. So if we look at, on the right, our building blocks, our foundation company standard, our training, risk assessment, schematic, and validation, and we compare it back to the UK study that we showed at the beginning of this presentation, we can see that all these building blocks really cover a lot of where these machines went wrong in these tests. So, our specification will come, the correct training and teaching people about technologies and what to use. And also, we'll get into it a little bit about also component specification. Risk assessment really determines what kind of, again, goes to our specification. What are we using to correct the hazards? Design and implementation, our schematic review. We're looking at a lot of things now. We're looking at all of our energy sources. We're looking at our safety PLCs, and then we have validation, which really are installation and commissioning. We're checking the cell right before it goes into production physically and determining if it's reacting the way it should. So the building blocks and the mindset we have on the right really covers a lot of what we have from the study in the UK. Now, additional items, changes after commissioning. These are things we have to look at. Who's going into the PLC and changing things after the fact? Do they have the right authorizations, or who's doing that again? And that could be fixed as well. But again, I still feel that a lot of that will be covered in validation. Now, if we look at our company standard again, right, our foundation, if we look at that, and if we look at consensus standards, and again, consensus standards are what OSHA refers to when you need more detail on how to design something safely. And the consensus standards we said at the beginning, we said that we want to determine which ones we can use for our facility. We want to simplify them and put them into a company standard without the vagueness, with more explanation. But If we look at company standards, typically they're updated by a council every 4 years, and that's not necessarily true. Some take longer, some take shorter. I wouldn't say shorter, but some take longer, 4 years, and they're constantly being reviewed, right? But the reason why is because, our industry is constantly evolving and changing with technology. So therefore, to keep up with change in technologies, these standards get updated, and it's important. Now, this would be the same for the company standards. So if technologies have changed for the better, allowing for production to increase, I feel this should be the same reflected in your documents. So we need to update this. It's a living and breathing document. For example, there's a technology called PSDI or cyclic. It's the same thing. Manufacturers call it two different terms. And what it is, it's an item on safety light curtain. And what it looks like essentially is an automatic reset. And now we get asked all the time, can we do automatic reset? No, I'm sorry, you have to have a manual reset. But people like automatic reset on light curtains because it makes their production move faster. Well, PSDI and cyclic is essentially that. It doesn't allow it. It's a lot safer. It's not an automatic reset, but it looks like one. Now, a lot of people don't know about that technology, and safety standards allow PSDI now. So if you're updating your standards, the standards are updating, and you can update this. You can offer this to your staff, to your engineers. So the people there that we tell them, oh yeah, there is a PSDI technology you can use that allows for automatic reset. Now, you may not like that as a head of EHS. You might not like it. Doesn't mean you have to add it. However, if people are asking for it, it's something you can offer. And it's just a simple case that, my job is to know standards and technology for safety, but the job of an engineer at a facility or a machine builder, their job is to run production, make things work, or know how to build machines. I'm supposed to be the expert to do that. But if we're putting these technologies and we're updating them, constantly putting in our book, when our engineers, our maintenance people, our EHS refer to this company standard, they'll see that this device, I never knew of it. And the person that came to us with the emergency pull cord as a safety device for the wrong application, if they had a book for that, they could refer to it to see that there are other technologies for that to use to keep things safer. Another example is, I've seen some standards 15, 20 years ago that were cutting edge, were awesome. But when they weren't updated, they became dinosaurs. And they became dinosaurs and no one used them, to the point where I think even OSHA was even referring to these and saying how they did them. But if they don't get updated and evolve with technology, they become dinosaurs. So, and what happens when it becomes a dinosaur? We talked about at the beginning of this presentation, we drift back into relying on our own idea of safety. We see this book, we see it's old, we see it's not with the times, and we say, you know what, I think this is safe, this is better, and we want to get away from that. Now, part of that, again, the UK study was specification and components, and we talked about in the last slide a little bit, is knowing technologies, what technologies are out there. It's an important part. Now, this part is obviously, standardizing on components, but picking the right ones. It doesn't matter whose, it doesn't matter if you have multiple components from different companies. Just the fact that you can put it in your company standard, and again, giving the idea of the engineers, maintenance, and EHS an idea of what technologies are out there, right? You can also have wiring diagrams that we showed. You can have examples, safety PLC programs. Now, not the whole program, because that could get a little crazy, but function blocks and what they do. It adds awareness to new safety technologies. A big thing I did years ago was I created a safety book for the team I was in a past position. And in that book, I put, an application engineer's information, direct line, phone number, and email. So if you're somewhere in your facility is having a hard time with something, they can call a direct application engineer. I know now, like 15 years ago, we didn't have chat services, and we try to get better with our 1-800 numbers and connect to someone. But I still think it's a good value to have someone in application engineering from that company that you can call directly for help and information like that. So it eliminates a lot of guesswork, and it helps with consistency. So I think that's an important part. So, and if you add these, and it might be from different companies, these companies will share information to better help you. And they'll also say, hey, we've come up with some new safety technologies. Maybe you want to add this to your standard. And you can be the judge and what things might work for your facility. So as we conclude this presentation, now a lot of the things that we talked about, right? The nice thing is on the right, these building blocks, it's from examples we've seen work over our time in safety. It's things we've seen that have dramatically decreased incidents at facilities. It does take some work, right? But there are challenges, right? Easier said than done. Where do we do it? And I can't help but think, there's some people that may be thinking like, do we have anyone that knows how to even do a risk assessment? You may have people that do great risk assessments. You may not have. You may not even know if you do it. There might be a facility that's doing them you don't even know about. Right? You may have someone, but how is he or she going to travel 30 or 40 facilities to start training people? Right? How do we offer this? Where's the resources? You might have an awesome safety company standard that you developed and an awesome idea, and that happens, but now you don't have the resources. While we have 10,000 machines, how are we going to deploy this? How are we going to have the resources to do that, right? So the idea is there's other things. Who will monitor the standard when it changes? Who's going to, I don't even know where I'm going to be in 4 years or 5 years. Who's going to constantly update this? Right? There's ideas that we're wondering about and thinking in training. Where do I start with training? Who do I do that? But the answer to all of these questions here, and the answers to do that is there's third-party assistance that can help with that. And so the goal where I urge you to do that is that there is third-party assistance with this that you can help. But the goal is that you want to use that third-party assistance as a means to train you, as a means to train you to do that. So if you have a third party and say, look, we don't do risk assessments, we want to hire someone to do risk assessment, I want to basically bring them on and have them train your first employee and do a multiple number of risk assessments until that person feels comfortable. And then at that point, that person can now start training others in your company. And until then, you could use the third-party company to do that, but you're slowly training them. Another thing, schematic review. You might have people that can look at the mechanical, but not look at the mechanical, but they don't, maybe they don't feel comfortable signing off on the electrical or the hydraulic or the pneumatic. But you can have them review it to a point, send it to a third party to sign off on it. Validation. You might not have the resources. You might have so many machines. You only have 2 people. But again, slowly you can have those third-party companies help you to point you grow when you build this mindset, and then from there, you're off and running. So it does take time. There are third parties, but I urge you to use those third parties as a means to get you started in building your own mindset. So I hope that helped. Thank you, everyone, for joining. I hope I answered some of your questions, and I'd like to open it up to question and answering.
Very good. Thanks, Peter. A lot of great information in there, and we're going to be getting to our questions here in just a second. If you'd like to submit a question, type it into the question window on the side of your screen and hit the submit button. And while we're answering your questions, please also complete the feedback form located at the bottom of the screen. We're also going to be joined by Isaac Nash-Bay, who is a Senior Applications Engineer with Epson, who will be helping us answer some of the questions today. A lot of questions have come in from the audience. We'll start with this one. What methods have you seen work to get our people to follow the company's standards?
Oh, it's a great question. So that's a great question. Yes. What we've seen, and this was new to me, is something I wouldn't have thought of, but I thought it was great, is the company standard is the most important in my opinion, because you're setting the tone. But what we've seen is that when you deploy it in certain areas, so a company that had multiple facilities around the U.S. Would put a 2-day training, a 2-day meet with everybody, and multiple facilities in the area would come, and they would have they would talk about the standard themselves, and they would have some of the component companies in there to discuss a certain portion of it to do that, and they would do that about 3 times a year, and then each quarterly, and then from there they would continue. So it was a training and an awareness thing about, hey, these are the updates. These are some things that have come to date. This year we had less injuries because of this. This is what we're doing. So I think people like the information to do that. So that was one thing that really helped, that quarterly kind of training, but to include basically third parties if you need that, to include some component manufacturers if you need that, and only have them there to discuss the more like an educational topic, you don't want it a salesy thing. You want it to be educational. I hope that answered your question.
Very good. Let's talk about another one along those same lines. You're talking about internal safety standards. Question is, what if our suppliers use their safety standards and these changes add to the cost of the machine?
Yeah, this one we hear a lot, and a lot of times, and it's true in the sense that, I think what happens, and again, I want to be very respectful of this topic. What happens is, you're buying the same machine, and there's, the design has been established, but now you want some new designs and new features that are put on. There's that initial design change, and it costs some money. But what I've seen done is that the team that went there, they sat down and they looked at the exact design changes, and they determined that it wasn't that cost. The cost, that delta of that change, wasn't nearly as high, and they came together and found a way to change the design where it met the current standards, because the old ones were old, and as we know, safety is not grandfathered in. They came to that agreement, but they also made changes and with special pricing and such. So I think at that point, when you look at the quote, you get nervous. You're like, we can't do it. But visit with them, talk with them, go through line by line, and determine what it is, and you'll see that there's costs in there that can be removed. And I've seen that done multiple times with these new company standards. So, and again, it's only a one-time thing, and from there, it's changing. So I hope that answers your question.
And let's talk about the other end of the process. After the machine's been put into production, who do we allow to make changes to the safety on the machine?
Yes, another good question. This is something that I get sticky about, because when there's safety, in my opinion, and I've worked in facilities, I was a controls engineer in a facility for years, and there's always changes happening to the process side. I'll agree there. Things have to change. However, in safety, it's usually on and off. You close a door, you get a signal, it's closed, it's good. So the only time safety gets upgraded is if you're adding to that cell, in my opinion, right? People might disagree with me, but I don't think that you have to my point is that I don't think you have to get into a safety PLC as much as you have to get into a process PLC. And as an example, so who's changing that? That means there's less activity there. So I feel that EH&S has to be involved, or a control. So when we look at our risk assessment and we have our controls expert, the person that's looking at the controls part of the risk assessment, they should be involved in what changes happen. Now, if it's a mechanical change, they want to move guarding, then our mechanical expert gets involved. And they have to be involved in that decision to determine that change. I hope that helps answer your question.
It's one of those things with safety, is that there's safety at the device, and then there's safety in the process, both the human process and the operational process, and all of those things have to be coordinated.
Correct. Yeah, we want the right people involved, and when you have people making changes, although safety PLCs are recording that stuff, it's still not good practice for our mindset. We want to have the right people involved, and to be honest, again, it's arguable, but I really feel that a safety PLC shouldn't have to have the changes of a process PLC. So it's not often, but when it happens, the right people should be involved, meaning the experts in that section of safety, and we can revert to our risk assessment people as well.
Good. Another question, our facility has many standalone machines with multiple designs and products. Where do we start with the upgrading?
Right, yeah. So that, yeah, of course, and how we recommend doing that is, again, I'm a big believer in risk assessment. That is basically the example I use is it's like bringing your car to the mechanic. There's something wrong with it. We have to pop the hood, determine what's wrong, and then once we determine what's wrong, we know how to upgrade it. Well, a risk assessment is very similar. A risk assessment will tell us where the risks are and how high they are. Do we have high or low? So if you have a facility of machines that are individual, you do a risk assessment across all of them, and then at the end, you prioritize. You see, okay, across my 50 machines, these 25 have very high priority. They have very high risk. I'm going to take these ones, and I'm going to start my upgrading process there. And the low machines, although it's still important to have a plan, they shouldn't take precedence over the higher priority machines. And so risk assessment software that you use, that we have, people have, or third-party companies have, can tell you the priorities, can initialize which are the priorities. You have it in Excel, you make a bar chart, and these are the very high ones, and you can single them out, and then you develop a plan and take it from there.
Another audience question, if an in-house device is built, should it be evaluated by UL or another third party?
Yeah, so an in-house, I'm assuming that's an in-house safety device. In some cases, that is needed. There isn't a safety device that accomplishes that. What I suggest doing there, the beauty of ISO 13849, for example, the beauty of that standard is that you can take that standard, and that standard is the performance levels I talked about, A, B, C, D, and E. Well, that standard, sure, we can take a safety device and determine its performance, but the beauty of that standard is that you can take any mix and match device and you can put it together as long as you have, certain values. We call it B10D. They're the values of how long this equipment can work for before it fails. And you put it into a calculation, and that calculation, which is Sistema that we talked about, that Sistema calculation will tell you a performance level. So at that point, you have a performance level. Now, and at that point, and that's something a third party can help with, where you say, hey, we can't find this system we need. We want to develop it our own. So here are the devices. Can you calculate a performance level for us? And then again, you get your Sistema document. It tells you it's this performance level. You record your parts. And so that's the way you should go about it. You don't necessarily need to go to TUV to do that. Although that's good to go to TUV, but you don't necessarily need that because that's the power that standard offers, for example.
This is a really good question because it goes right to the heart of the problems with safety and the human condition with safety. The question is, as a machine manufacturer, we found changes for safety with risk assessments, but sometimes our customers don't want the changes and want what they've always had. Do we have liability if we sell them with the safety changes if we think the customer is going to remove them?
Right. Yeah, I think, I'll answer that to a point, and I would say always, I'm not a legal professional. I'm not a legal counsel by any means. However, the way I know it, the way standards are based in North America at this point is, rules are, it's the responsibility of the employer to offer a safe machine, and it's not the responsibility of the machine manufacturer. So in your case, you can offer it to them, but at the end of the day, it's their responsibility to keep the employer safe. Now, if this was Europe, in Europe, it's the responsibility of the machine builder to develop a safe machine. So I don't know what happens in that circumstance there, but being that it's the responsibility of the machine manufacturer there, I would assume they would have to sell it to them with the required safety.
Sure. And this is along the same lines because, we've seen this happen particularly with veteran technicians. The question is, what's the best way to get operators and technicians to adopt the safety eye you discussed, since they're the ones that work with the machines all day?
Yes. That's a very good point. Operators know the machine better than anybody. The first machine I designed, I thought it was awesome, and 6 months later it was all bypassed because I made it bulletproof. And so how are they able to get involved? I really personally think that when you put them in a training and you are transparent about the injuries that have happened company-wide or within other companies and the regulations of why, so you show them a few injuries. For me, like I talked about at the beginning of the presentation, when I saw the injury, I didn't see it physically, but I heard of it after, the molten metal pouring on that operator, I started to take things very serious. So I think if you are to share in a training transparent of injuries that have happened and why it happened, I think at that point, operators will be more friendly to come. And I think it's very important to tell them that you're not here to make it bulletproof. You're not here to make their job harder. You want to work with them to keep their job the way it is, but hey, there's new technologies there that we can implement, and assure them that the design we're going to come up with, we're going to share with you and see what you think. Because at the end of the day, some might say, hey, it's too much work asking all these people if we're going to do it that way. But you really want production to flow. Production really matters, but safety is just as important. So we want to make sure we get it right the first time, design it right, and if you involve them in the process, I think that says a lot.
Yeah. And I think you have to discuss the human cost and the financial cost. We talk about safety, but safety is cost avoidance. It is not having to pay for the injury, for the time off, for whatever might happen from an OSHA standpoint. Safety is something that is a benefit to employees, and talking about it as a benefit as opposed to a cost center is always a valuable discussion.
Yeah, I would agree with you, Bob. We've seen some studies where I've read studies, and for $1 of spent in safety, you save $3 on fines. There's a lot of that as well. And obviously it matters more to keep people safe, but there is the financial side of things. Of course, I would agree.
Okay. Absolutely. We talk about safety as we talk about maintenance as a profit center as opposed to a cost center, and I think there's a lot to that. Another question's come in. What's your advice regarding safety zones on the system of machines? Many times it's not practical for a single e-stop for an entire line.
Yes. Another good question. Yes. So zones for sure. I mean, if we're looking at multiple zones. Now, for me, and it comes down to the designer, my opinion is that as a zone, if I stop this zone, because if I stop zone 1, for example, but I physically now, I can't walk over to design 2. So if I have a robot cell and I open zone 1 and that's a robot and it stops, and there's a zone 2 next to it, I can't crawl through there and get into zone 2. Then I feel that's okay. Now we're at the safety device level. Your question was about the e-stop level, and that's a question that I think we always have. Now, if you see someone in zone 4 and you're in zone 1, and someone in zone 4 is being hurt, you panic, because that's what an e-stop's for, is for someone else to hit it, not for the same person. If you're in zone 1 and you hit zone 1 and it stops zone 1, but it doesn't stop zone 4, what are you going to do? So I'm of the opinion that e-stops are global, meaning they should stop the whole line. However, that sometimes doesn't work for production. You might ruin production. So it's a great topic for me. It's something I've struggled with in my career. Unfortunately, you might not like the answer. I always put it in the customer side. Well, what do you want to do? But it's that one circumstance that hits me. If I'm in zone 1 and I see someone being hurt in zone 4 and I hit an e-stop in zone 1 and zone 4 doesn't stop, what do I do? Because at that point, if I don't know the system well, I'm going to run around like a crazy and start hitting everything maybe. Who knows what I'll do? So personally, my opinion, again, I stress the word opinion, is that it should be global and it should stop everything.
It's always important, though, to have the discussion, and safety is a continuing discussion. It's not an event, so that's very important to look at. And here's a question that kind of related that. We have time for a couple more questions. Do you suggest people working on the machine's safety review in separate parts, such as risk assessment or validation?
No, I think it could be the same person doing the risk assessment and the validation. I have no problem with that. Although separate second sets of eyes is always good. Here, internally we'll always have a separate set of eyes to look at it. But at the same time, if you have a controls engineer that has, for example, reviewed the controls and has done it, and then when they go to do the validation, they know the system more intimately, and they can go through it. But it also could lead to mistake. But I'm of the nature of, if we have a resources issue, no problem. Have that same person do it. But if you have multiple resources, I would mix and match projects to just have a separate set of eyes, because now the person who did the validation portion might see something on the controls review that doesn't really work well, just by simple error. We've all had it. I mean, you saw the example I used with the robot I missed, and I could have hurt somebody, and my boss at the time caught it, which is great, and that's why we work together as a team. So I'm okay with, because of a resource issue, you don't have it, but if you do, I would use multiple people to mix and match.
Very good. We have time for one more question. Are you simplifying safety circuits or a company standard by only allowing a minimum of a performance level?
Yeah, and so I think where that comes, and you're not simplifying the circuit, because performance level D, in reality now, a lot of devices come and we can meet PLD, I would say, easier than in the past. So the question, if I understand it correctly, the D level, yes, it has more redundancy. It has monitoring. There's more to it. But what I think you're simplifying is the fact that you get your team used to knowing performance level D, and instead of them saying, "Oh no, this one's C," and you're like, "Okay, well, what is C? Do I need like a common cause field? What do I need to get to C?" So you're changing the mind of someone. So you're requiring that person to know 3 or 4 different levels of design, where if you say D, they know that off by heart. And again, there's more components involved. However, you know D inside and out. You look at a circuit, you'll see monitoring isn't there, and you'll do it. So it adds simplicity to knowing one circuit, and it adds simplicity to catching more faults, because you're always looking at the same level of design, if that helps answer your question.
Absolutely. Well, we love talking about safety and the maintenance of safety. So this has been a great topic, and I want to thank Peter Rogakos for his great insights into today. I want to thank all of you for attending this afternoon, And on behalf of Machine Design, New Equipment Digest, and EHS Today, I'd also like to thank Schmersal for sponsoring today's event. And of course, thanks to all of you for joining us. Have a great rest of your day, and of course, stay safe out there.